Hello, welcome to 5.1. I think this is video 4 for chapter 5. This is Miss Moreland, and we're going to get started with identifying linear functions. This video is going to be very short, and you'll notice in your notes there's just 3 spots where you have to take examples down: the graph examples, the equation examples, and the table examples. So we're going to start by identifying from a graph because that's the easiest. So a linear function is a graph who forms a straight line. So if I go here, I'm just going to grab the tool so I can actually draw a straight line. So a linear function is something that looks like that, that, that. So on your paper for linear, draw any example of lines that you want. Okay, and then nonlinear would look something like this. It has to have a curve of some kind. It could be like that. This one is the absolute value that we learned earlier. And that one, even though it's made up of 2 separate line parts, it's not linear because it's not one straight line. And then another one that you might be familiar with that's not linear is the U shape, which is a parabola. We'll learn about those later on. That's not linear as well. Okay, so write down the couple for nonlinear. If you need to pause it and go back, go ahead. Graphs are pretty easy for linear, nonlinear. Okay, now we're going to look at equations. So again, you've seen this is your 3rd time seeing this now. Slope-intercept should be ingrained in your head. Y equals mx plus b, where m is the slope, b is the y-intercept. Point slope is y minus y1 equals m times x minus x1. And that's if we don't know the y-intercept, but we know another point. That's our y1 and our x1. And standard form is the one we don't use a lot, but you see it. It's ax plus by equals c. And remember, there's no fractions allowed. So if I ask you to convert to standard form. Now, the nice thing about today's lesson is you're not going to be converting. You're just going to be sorting. So we're going to look at this, pause the video, and see if you can copy down which our equations are linear versus nonlinear. Okay, so I'm going to start with this one. This one is linear. This one is linear. All you would have to do to get that one to become linear is combine these two terms to 6x minus 8. And now it's in the correct form. Nonlinear, it has an exponent of 5. We're looking for an exponent of 1 on the x. Nonlinear, that's the U shape that we learned earlier. This one is in point slope form, so it is linear. And again, if you wanted to convert it to your favorite form, you could distribute. Whoops, not 4x plus 3. 4x plus 4 times 3 is 12. Could add the 7 over, and you'd get y equals 4x plus 19, and now it's in your standard form. Your y equals mx plus b, not your standard form. This one has the little bars around it. That means absolute value. That's nonlinear. This one's kind of tricky. It's in point slope form, but the x coordinate is 0 on that. So all I'd have to do is add the 8 over. And I would get y equals 4x plus 8. And now it's in my y equals mx plus b form that we love so much. This one is in standard form. So that's linear. Let's move this out of the way. Let's grab this one. This one is also in standard form, so it's linear. And this whole chunk down here is linear. This is a horizontal line, remember? So that's linear, side to side. And this one, remember, is a vertical line, so it is linear. And that very last one we haven't gone to yet is also linear. It's in point slope form, and you could distribute if you wanted. So if you look at this, really, equations aren't that bad either. You're looking for y equals mx plus b. You're looking for point slope form or standard form on this side, and anything with an exponent is not good. Anything with something around the x, like bars, is not good. However, you can have parentheses because that's point slope form. So don't look for exponents and look for bars. That gives you an indication it's not linear. This one's actually going to give you the V shape, and this one's going to give you a U shape. The last thing we're going to look at is tables. So tables from a linear function. If I have a linear function, it would be this one. This is the easy one. Notice that my x's are going up by 1s each and my y's are going up by 2. That would be linear then because they all are going up by the same amount on the x and the y. So we're going to go into a couple examples. Oops, excuse me. So these are the two examples we're going to look at. I'm hiding the one so we can just focus on this one. So if I look at this one, I always want to make sure that my x's are going up. So you check to see, okay, they're adding 1 each time. And the y's, the change in the y's, to get from -5 to -2, I'm adding 3. To get from -2 to 1, I'm adding 3. 1 to 4, I'm adding 3. And 4 to 7, I'm adding 3. So ideally, you want the slope to be the change, and you take the change in y over the change in x. So all of the slopes are 3 over 1, 3 over 1, 3 over 1. So this one is linear. Okay, let's look at the second one. So notice now our x's aren't going up by the same. So I'm adding 1, then I add 3, then I add 2. And this one I add 2, I add 6. I get from 6 to 10, I add 4. So now this is where I actually have to find each slope. So remember, slope is change in y over change in x. So I'm going to take the slope of this one is 2 over 1. Let's change the color of that so you can see this is the slope. Slope of this one is 6 over 3, which is the same thing as 2. The slope of this one, whoops, ignore that. Slope of this one, it's 4 over 2, which also equals 2. So even though they didn't have the same change in the x and y on both sides, notice that when we find the slope, it's all still 2. So this one is also linear. If these didn't all equal 2, it would not be linear, right? So maybe I'll give you one more to end it. If I were to erase this one, I'm just going to completely make one up. So I have x, y, and I do 1, 3, 6, and then I do 2, 4, 6. Some of you are going to go, oh, it goes up by 2. It goes up by 2. That must be linear. However, if you look on this side, it goes up by 2, and then it goes up by 3. So 2 over 2 is my slope, which is 1. And 2 over 3 is my slope for that one, which is not 1, so this one would be not linear. And this one isn't in your notes, but I did want you to see one before you move on to the on your owns. So get your on your owns done tonight. Keep in mind, a graph is simple. It's either straight or it's curvy, nonlinear. An equation needs to be in the form y equals mx plus b, point slope, or standard. Again, things to look for is squared, that's a no. Absolute value, that's a no. Okay. And a table, you want it to be the same slope. Okay. All right. Have a good night.